Rainfall is a vital factor in shaping ecosystems, significantly impacting soil moisture and nutrient availability, and determining the type of plant species that can flourish in various regions. The diversity of plant species is essential for ecosystem resilience, as it supports services such as wildlife habitats, soil stabilization, and the replenishment of atmospheric oxygen. It also helps levels of biodiversity contribute to increased ecosystems, productivity, and adaptability. So, is there a relationship between rainfall levels and plant species diversity, with a more temperate environment found in the American woodlands? To get that answer, first we have to understand the correlation between the two and how crucial it is to develop effective biodiversity conservation strategies. Data is collected through field surveys that employed standard ecological sampling techniques to evaluate plant species across various habitats. Monthly records over several years were obtained from national meteorological stations to represent regional rainfall patterns and precipitation data accurately. From 2014 to 2017, cytologists collected plant trait information for 32 common species, chosen based on their ranking from mean long-term abundance in both grazed and ungrazed locations across the CPER, also known as the Certified Park and Recreation Executive. Species were characterized as bramoids, forbs, shrubs, subshrubs, and annuals and preannuals based on the USDA plants database. Here we focus on 11 plant traits identified as theoretically likely to influence precipitation density by mediating a plant's ability to withstand water stress and or grow rapidly. Focal traits include SLA, or specific leaf area, leaf nitrogen, leaf phosphorus, system-specific density, leaf osmotic potential, or OSM, leaf thickness, leaf pubescence, leaf dry matter content, or LDMC, leaf area, plant height, and change in 13C. The 13C ratio of leaves expressed relative to the 13C ratio of the atmosphere, a proxy for C isotope discrimination and water usage efficiency during photosynthesis. Leaf 13C was calculated as follows. The sensitivity of plant growth to annual precipitation was calculated for 32 species. 10 graminoids, 18 herbaceous forbs, and 4 shrubs or subshrubs. 10 were annual species and 22 were perennials. SSPP represents the proportional change in species abundance relative to its average absolute abundance for every 1 millimeter change in water year precipitation. For example, a species with an SSPP value of 1.0 would increase by 10% with an increase of 10 millimeter water year precipitation, or double with an increase of 100 millimeter. SSPP ranged from positive 2.2 to negative 1.2% millimeter. For most species, SSPP was positive, reflecting greater abundance in high rainfall years and lower abundance in low rainfall years. We found substantial differences in SSPP between annual and perennial, with perennial species having on average 86% lower sensitivity than annual species. Of the 11 traits examined, 6 were identified to be statistically significant. P was less than 0.05, cross-species correlation between plant traits and SSPP. Alternate leaf species with more outstanding stem-specific density, negative leaf osmotic potential, and greater LDMC, leaf dry matter content, generally has low SSPP. LDMC was the trait most strongly correlated with SSPP. We did not find significant correlations between SSPP and leaf thickness, pubescence, leaf area, plant height, or leaf carbon isotope discrimination. The study of U.S. woodlands investigates the role of plant traits in predicting species and community performances. Focusing on these traits respond to variable precipitation. It reveals that psychological and morphological characteristics significantly influence species sensitivity to precipitation changes. Two main spectrums were found, a leaf economic spectrum and a drought-tolerant spectrum, both critical for species response to altered water availability. The researchers predicted with increased precipitation, communities may shift towards species that lack drought tolerance but have a rapid growth trait. Despite stable average precipitation levels, the region experiences more severe droughts, potentially leading to a greater abundance of species with low specific leaf area, SLA, high leaf dry matter content, ODMC, and less harmful osmotic potential, OSM. During dry years, this underscores the importance of maintaining drought-resistant species for ecosystem sustainability. The findings suggest that continuous traits offer advantages over traditional functional classifications, enhancing understandings of community responses to water fluctuations and highlighting the importance of considering drought tolerance and economic characteristics in predicting future community structures.
The dog was more at her than she would say anything. And then all of a sudden one day I took the cover off of her and she started talking. You